Okay, this problem number 9 says sine of 4x minus 2 sine of 2x equals 0. So just like the last problem, we want to get the same trig function, but the same trig function isn't going to be enough. We need the same angle. So we're going to try and get terms that have the same trig function and the same angle so that we can use some factoring techniques. Once we factor, we set it equal to 0 and use the zero product property. So I know, looking at sine of 4x, that I can use the double angle formula, which will bring that angle down to 2x. So the sine of 4x is 2 times the sine of 2x times the cosine of 2x. And then we have minus 2 times the sine of 2x equals 0. And now what's common to both? Well, a 2, so I can factor that out, and a sine of 2x. Can factor that out. So we factor out 2 sine of 2x, and in the first term, that's going to leave us cosine of 2x. And in the second term, when we factor it out, we just get a 1. Now I can use the zero product property. 2 times the sine of 2x equals 0, and the cosine of 2x equals 1. I just added that 1 over. When I set this equal to 0, add the 1 over, and I got it. Now if I divide both sides by 2 on the left-hand side here, divide by 2, I still get 0. So what I could have done was I could have said, look, I've got a factor of 2, I've got a factor of the sine of 2x, and then we've got that factor of cosine of 2x minus 1. We've really got 3 factors here. Well, 2 is not a variable factor, so I don't even need to write that down. Just the sine of 2x equals 0. Now remember, when you're solving multiple angles, you need to find all the solutions first. I don't know if this was a 0 to 2 pi. I'm thinking that it probably was. But you need to find all of the solutions first. So all of the solutions, 2x equals, well, what would this angle have to be so that the sine of that angle equals 0? Well, it would have to be 0 plus 2n pi, or pi plus 2n pi. But if we notice where 0 and pi are, we don't have to go from 0 and then all the way around. We can go from 0 to pi. We can go from 0 to pi just by adding an n pi. So add pi, that gets you here. Add another pi, gets you back to the positive x-axis. Add a pi gets you to the negative x-axis. Add a pi gets you to the positive x-axis. So I can rewrite this as 0 plus just n pi. Then I'm going to divide by 2, divide by 2, divide by 2, and all of my solutions, x equals 0 plus n pi over 2. I'm going to pause right there, and I'm going to solve the next one. So what angle do I put in for 2x that is going to give me an output of 1 for cosine? Well, that is going to happen at 0 plus 2n pi. I divide by 2, divide by 2, divide by 2, and I get x equals 0 plus n pi. Well, this solution right here is going to get all of these solutions. If I put a 0 in for n, I'm going to have 0 plus 0. If I put a 1 in for n, I'm going to have 0 plus 1 pi over 2. If I put a 2 in for n, I'm going to have 2 pi over 2, which is just pi. If I put 3 in for n, I get 0 plus 3 pi over 2. And if I put 4 in, I'm going to get 4 pi over 2, which is just 2 pi, and outside of our interval here. Okay? Now, watch what I'm talking about. If we need all solutions, this is the answer. And I don't have to worry about this one because all of these answers on the right are included in the bubbled answer. Let me show you. So I'm going to do this in orange. If I put a 0 in for n, I get 0. Well, look at that. That's right there. If I put a 1 in for n, that's pi. And look at that. That's right there. And if I put a 2 in for n, that's 2 pi. But 2 pi is outside the interval because 2 pi is not included. So all of my answers from this equation are already included. So if they were looking for, not sure what they were asking on this one, if they were looking for in the interval, then these are our answers. If the interval was not there, then they're looking for the blue bubbled answer, all of the solutions.